In this tutorial, we are going to look at inverse logarithmic properties. Just like taking the square root and squaring an expression cancel each other out, exponential and logarithmic operations undo each other since they are inverse operations. Since a log is just an exponent, if we have log base b of b to the x equals x, we can rewrite it as, remember, if I have this x right here, I can multiply by x because log base b of b is one exponent and we're raising it to an exponent. So it's x times log base b of b equals x. And that's based on the power property. It makes sense that log base b of b would give us an exponent value of 1 because b to the first equals b, and writing it in logarithmic form would be log base b of b equals 1. And that would leave us with x times 1, because log base b up here, log base b of b is 1, so x times 1 equals x. And then 6x times 1 equals x. X times 1 is really x, so we have x equals x. So we're proving the fact that if we have log base b of b to the x, it does indeed equal x. It would leave us with the exponent 1, since a log is the exponent, times the exponent x. Remember that log base b of b was raised to the x power, which is x. So basically, if we have a log with the same base as the value raised to a power, it's just the power. So similarly, if we start with b to the log base b of x equals x, then essentially the b and the log base b cancel each other out and we are left with the x. So basically these cancel out and we get x equals x. Therefore, we have our inverse property table. Log base b of b to the x just gives us the exponent, and b to the log base b of x just gives us the value x. So over here on the right, log base 10 of 10, this actually equals 1. And when we have a power, we have 7 times 1, which is 7. And then we have 10 to the log 10, which cancel out, and I just get 2. And that does indeed equal 2. Okay, let's take a look at some practice problems. So in number 1, we have log base 4 of 4 to the 7. We know that the 7 comes down in front. Log base 4 of 4. We know 4 to the first power equals 1. So this becomes 7 times 1, which is really 7. Go ahead, pause the video, try number 2. For number 2, we have to look at log without a base is really base 10. We just don't write it. And then 10 or 100 is really 10 squared. And that is raised to the 0.1. So we really have log base 10 of 10. When we have a power to a power, it's really multiplied, which is 0.2. And then we look at log base 10 of 10. The 0.2 actually is the power, so that actually moves in front. We have 0.2 times log base 10 of 10. Log base 10 of 10 is 1. 0.2 times 1 is 0.2. Go ahead and try number 3 for homework. Number 4, I have 7 plus x is my exponent. Multiply that by log base 3 of 3, which is also an exponent. Log base 3 of 3 becomes 1, so I'm just left with 7 plus x. Number 5, go ahead, pause the video, and try problem number 5. So problem number 5, we have log base 2. So I need to get 16 in a base of 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's 2 to the 4th. That is raised to the 3rd. So we have log base 2 of 2 raised to the 4th raised to the 3rd. So 4 times 3 is 12. We know that log base 2 of 2 is 1. And the 12 comes in front. So 12 times 1 is 12. Go ahead and try number 6 for homework. Number 7. We said that 3 raised to the log 3 cancels out, and I'm left with 4.52. Number 8, go ahead, pause the video, and try it. For number 8, we actually cancel 5 log 5 and just get 10. Do number 9 for homework. Let's try number 10. If I have 5 times log base 2 of 3x, I need to move that exponent first, because 2 to the 5th times log base 2 of 3 to the x we can't really do, so we're going to do 2 to the log base 2 of 3x to the 5th. Oops. So 2 log 2 cancels, and we get 3x to the 5th. Number 11, pause the video, try it, and come back. Number 11, we have 2.5 to the log 2.5 cancels out, and we just get 19. Go ahead and do number 12 for homework.